In this video, we're going to be going over binary expression tree. So what is a BET, a binary expression tree? So you have internal nodes, and these are going to be operators. An operator is plus, minus, times, division, and you're going to have leaves. Your leaves are going to be your operands. These are going to be numbers, 1, 2, 3, 4, 5. And you're going to have your left subtree and a right subtree. That will be your left operand. This will make more sense when I show you. Right subtree, and that's going to be your right operand. Your operands, these are your numbers. Your operators, these are your symbols. So in your subtree, let's say we have the expression 3 plus 5 times 2. You have times here. That's going to be, you're going to have plus 2, and you're going to have 3 and 5. But there's a pattern here. So as you can see, as you go left to right, it's going to be the same thing when you're looking at it, at your tree this way. So going left to right, you have 3 plus 5, and then your next thing that's on the way to the right is your times, and then your 2. The only thing that your BXT doesn't show is no showing of your parentheses, but it shows your expressions and the order that they're in. So that's a really easy way. If you're given your expression, you can just get the tree, and if you have the tree, you can just easily write the expression. So now we're going to work on the traversals. Most specifically, we're going to do post-order traversals for our BXT trees. Post-order. So when you have post-order, this means you go from left, you evaluate the left, then you evaluate the right, then you evaluate the root. And we're going to do this with stacks as well. So let's do this one. How are we going to get our postfix form? Our postfix form here is going to be 3, 5 plus 2 times. But how do we get this? So first, in your thing, we see we have 3. So with our 3, let's see, 3, we're going to push 3. So here's our stack. We'll make a stack here. Now, after this, we see 5. So we can pop 5. Or, sorry, we just cross out 5, don't say pop. Then we push that onto the stack. Now we read plus. Plus is an operator. For operators, what you're going to do is you have to pop twice. Operator. So you're going to take your plus, and you're going to pop 2 expressions. So now you're going to have 3 plus 5 equals 8. And you're going to take this result and you're going to push it. Back onto the stack. So now your stack just has 8 on it. I'm going to put this with our work right here. After this, we have to do 2. So you read 2, and you're going to see that that's a number. For your numbers, those go straight to the stack. And for operators, you pop them twice with two operands. So you can do an operation. To do an operation. So, and then after you do that operation, you're going to get a result. After you get the result, you are going to push that onto the stack again. So you have your 2 right here that's currently on the stack on top of 8. So this is your stack, your 8 and 2. So now after this, we see our times. So times, this is an operator. So you're going to pop twice. And that's 8 and 2. You're going to have 8 times 2. That's equal to 16. And then you're going to take the result and you're going to push 16 back onto the stack. So you just have 16. And you did this correctly. Correct. Because there's only one value left on the stack. Whenever you have your correct work for evaluating a BXT, you only have one number, one thing in your stack left. If you have more stuff, then you did something wrong. Okay, let's do a second example. Let's say we have the expression 7 minus 2 times 4 plus 1. Our tree expression is going to be like this. So we can just do this left to right. So 7 minus, and then you're going to have 2. And this makes sense logically. You're like, you see 7 minus 2. You see the result. You use GEMDAS or PEMDAS, your order of operations. You see, you have to take your result. You have to compute the addition and subtraction inside of the parentheses first, and then you take that and you multiply it times each other. So obviously, like, those are going to be in the bottom of your tree, and then when you have your total tree, it's going to be that multiplication. So 7 minus 2, and you have plus your times. Then you have here 4 plus 1 So we want to do the post order, traversal, post order. On the left subtree, we have 7, 2, 1, minus. And then on the right subtree, we have 4, 1, plus. And then you have the root plus. So your post order sequence is gonna be, okay, let me just put that plus here. You have 7, 2, minus 4, 1, plus times. But how can we do this stack evaluation? Stack evaluation here. You have your stack here. So first, what do we see here? We have 7, so we're gonna take 7. We're gonna push 7 onto the stack. Label this as my stack for only your operands. On our stack, we only have operands. So our stack is currently just 7. There's nothing in our output yet. I'll actually label this output. So then we have our 2. You're gonna push 2. Still no operators yet. Now we have our minus. Our minus, now we have to, you take your minus and you pop this twice. I'll actually write what we were doing earlier. Push 7, push 7, push 2. So, okay, after this, you pop these both. No, wrong color. And then that's going to be 7 minus 2 equals 5. And then you take your result and you push that. You push 5. So now after this, what we have is 4. So we're going to take 4 and we're going to push that onto stack. Push 4. And then after this, we see 1. So we're going to push 1. So 5, 4, 1. And after this, we see an operator, plus. So when you have an operator, you pop twice. So plus, pop twice. And remember that a stack is going to be LIFO, which means the last element in is the first element out. Like when you're standing in when you have like pancakes, right? Your last pancake that you put on top of the stack, you're gonna eat that pancake first before you eat the one at the bottom. So like when you have a bucket as well, you take the thing that's on the top of the bucket and then you take that out before you take the stuff that's at the bottom. So you have to take out 1 and 4 before you take out 5, even though 5 was the first one we put in, because the last one you put in is the first one out, just as the name is like saying. So you're gonna pop off 1 and 4. So that's gonna be 4 plus 1. The operator goes in the middle because that's just how like math works. 5, and then you're gonna push the result. Okay, now that's wrong color. Push 5. So 5 is now on the stack. So you have 5 and 5 on your stack right now. And then for our last expression, we see our last symbol, we have that. So time symbol. So you're gonna pop twice. Pop twice. 5 and 5. Pop 5 and 5. And now we're gonna have 5 times 5 equals 25. And then we are gonna take 25 and we're gonna push 25 back onto the stack. So that's gonna be 25. So now our final value is just 25, and we did things right because we only have one value on the stack left. So remember the expression tree expression tree evaluation, you're gonna use post order. Post order is your expression tree evaluation. First, your stack rules, your operands, they're gonna go straight push. I'll actually like make these different colors so you can like see. And your operand is push, and your operand is push, and your operators is pop right, pop left, compute, then push. Pop right, pop left, compute, and push. And finally, your final stack size should be 1. You should only have one value left in your tree. So if you have something important is if you have your first pop, that's always going to be your right operand. When you have your second pop, that is your left operand. So your B is equal to pop, and then your A is equal to pop. And then your result is going to be A operator B. Let's do one more example like we've done. So let's do our expression 8 divided by 4 plus 6 minus 3. So your tree, let's construct this. 8, 4, division sign. You can also put a slash if you wanted to. Plus, minus, 6, 3. Now let's do the post-order traversal. Post-order traversal. That is left to the right to the root. So for your left subtree, we have 8, 4, division. And then for your right subtree, 4 division. And for your right subtree, we have 6, 3 minus, 6, 3 minus. And then after this, we have our root, which is just plus. And I want to like make a black copy version of this so we can show the crossing off. So for this, now let's do our stack evaluation. Stack evaluation. Have our stack here. It's not. Okay, so first we are going to read 8, and your stack is going to push that. You push 8. After that, you have 4. So you push 4. Then you have your division sign. It's an operator, so you're gonna push that or pop that twice. So we're gonna pop those two. That's gonna be 8 divided by 4 is equal to 2. And you're gonna take that result and you're gonna push 2. After this, our stack is just 2. Now we have 6. We're gonna push 6. Your stack is 2, 6. Now you're gonna have to read 3. You're gonna push 3. And that's gonna be 2, 6, 3. Now we read the minus. And it's an operator, so you're gonna pop twice. We're gonna pop the two things that are on the top. So that's 6 and 3. So that's gonna be 6 minus 3. And remember, the one that is more bottom is gonna be the first one. And then the one that is on the top is gonna be the second in this thing. So just like remember which one goes first. 6 goes first, then it's 3. So after this, you have your plus. So you're gonna read your plus. That is an operator. So you pop twice. Oh, hold on. We didn't finish talking about this. Is equal to 3. Let's actually hold on for a second. Yeah, so you're going to take that 3 and you're going to push that onto the stack again. Push 3. So after you have your 3 is going to be your right operand, and your 2, no, actually I don't want to do that. So you push your 3. You're onto your plus. So we have our plus, right? So we're gonna pop twice. Take the things. Your 3 is gonna be your right operand, you have to pop. And then your 2 is gonna be your left operand. So that's gonna be 2 plus 3 is equal to 5. And then you're gonna take 5 and you're gonna push 5. So now all you have left is 5 on your stack. So some things that I want you to notice from this one is that every operator reduces stack size by 1. And the reason is because an expression at minimum, it's always going to be like blank plus blank, or blank divided by blank, that you have to have for the ratio of operators, of operands. Okay, actually operands to operators is going to be 2 to 1. So if you have an operator, it's going to slash off 1 operand on your stack. Also, again, your stack should always end with 1 value. Your right operand is going to be your first pop. And then your left operand is going to be your second pop. That's it.